Thank you, and apologize for the delayed start, so I appreciate you being very patient with me. Nothing like losing your power cords and all those things. Anyway, let me get started. So yes, the title is about stop hand coding and start using productivity tools. I mean, this is really the crux of, I think, what we're seeing in the Databricks community today. For I don't know how many years, it's been very much a data scientist, programmer-centric model. But with the advent of Databricks Delta, as well as moving into the larger data lakes and more use cases, what we're seeing is that Databricks is now being used as a data engineering platform. And very similar to the data engineering platforms of the past, think the client server world and the beginning of the data warehousing world, there were ETL tools that helped bring data into the environment and prepare and curate that data so that it can be used and consumed by the different consumers of the system. So let's talk about what and why and how that's going to work out for many other customers. And I looked at some of our customers that were using Talend for the purpose of data engineering on a Spark environment. There were some key statistics that really came up. Things like 50 times cheaper per gigabyte. Things like from 23 integration tools to 1. Things like twice the value for half the cost. These are key value metrics that our customers are seeing by using productivity tools as opposed to the hand coding that they had been doing in the past. Okay. When you look at what's actually driving those value benefits, there's kind of 3 key things that show up over and over again. First is the developer agility. So for the developers to be able to very quickly develop something, move on to the next project. The second is around portable data processing. As we've seen, from the migration from on-prem to cloud has been a massive move for organizations. And so having the portability to go from that environment to the cloud without having to redevelop your logic. That's kind of one aspect of it. And we'll talk about other aspects of portability in a moment. And the third, it kind of goes with the portable data processing, is the continuous modernization. As we looked at big data 10 years ago, the key technology there was MapReduce. Now MapReduce is really hardly ever used by organizations. People are using Spark and SQL, and so what we're seeing is that there's different technologies that come and go. And rather than having to rewrite your code, you should have something that can adopt and migrate with you in an easy way. So let me first say this. I do love coding. So I grew up as a programmer. For those of you, anybody ever hear of Borland and Borland C++ and Delphi? Okay, I worked for Borland for years. I loved programming because you can do so many different things. But because you can do so many different things, there's so many mistakes that you can make, there's so many different ways that you can do it, and not all the ways are actually really good. And so, what we're looking at, though, is how do you get the power of having a programming environment while having an agile and productivity environment. So that's what we're really going to focus on. So let's talk about some of the myths of hand coding. So, because anytime you get in there and people say, well, I can do this, for example, I can do it for less. I can just hire a programmer. I don't need to buy your software. I can, our guys know how to program in Java. We can do it for less. Okay? But once you start doing that, what you're incurring is a lot of technical debt, and you're going to be maintaining millions of lines of code. Okay? Another one is, well, we can optimize it better by hand. And this is the one where I would say, if it was a version 1 technology that I was talking about, you might be right. But we're talking, this is version 7 and with 10 dot releases, in between, so 10 years of development, and I guarantee you that the code that's going to be generated by a Talend environment is going to be as optimized or more optimized than what you can do by hand. Another one is, well, I can go out and hire the people that do this, and that's true. Okay, you can go out there. Oftentimes they're expensive. How many Spark AI developers are there in Amsterdam? And can you go find them and hire them very quickly? And then if it's not Spark that you need to use today, but something else tomorrow, where are you going to find those skills? And lastly, we need to be on the cutting edge. So this implies that you can't be on the cutting edge by having tools. And so the question is, how can you be on the cutting edge but never delivering anything or delivering one project where the other team is delivering 3 and 4 and 5? And so those are the things that we're going to talk about. Okay? So what do I mean though? So when we're talking about data engineering, the key things about data engineering is that it's about logic flow. I want to connect to this data. I want to do these steps to the data. I want to organize the data this way. I want to filter it. I want to transpose it. I want to transform it. I want to apply data quality rules to it. So what we're talking about is having a graphical tool to be able to push that out to the developer and then have that translate into the raw code. So that the developer's interface and everybody that's looking at it is looking at this high-level graphical based environment that's relatively easy to follow, as opposed to trying to look at low-level source code. So let's hear from one customer that's done that. Oops. So for some reason, it's not going on the audio. Let's see here. I'm looking at my AV guy.
And since we've begun our big data,
can you hear it?
Big data footprint alone is 3.
Right here. I'll just put my microphone up to it. We'll solve it the old-fashioned way.
16 petabytes of data total. And since we've begun our big data journey, our big data footprint alone is 3 petabytes. We think that the more information you have, the more hypotheses that you can develop, and ultimately the better discoveries that you can make. We are seeing the business get interested in understanding predictive analytics about the customer, artificial intelligence, machine learning. We're starting to develop competencies in understanding how to predict and anticipate what our customers will need and deliver a decision and a recommendation via digital channel. The IT benefits are significant. We see that the cost of delivery for our data is somewhere on the order of 50x cheaper per gigabyte. What we're also seeing with the use of Talend is a massive reduction in cost of delivery for our data transformations, in the order of about $13 million in cost avoidance. People need to get their hands on data and tools today, right now. I have a question, I want to answer it right now. That requires a lot of elasticity. There's no other way to do it than via the cloud. It really allows us to give a lot of different people access to the data and the tools that they need on demand. We're now able to do lots of innovative things in the lake. Our speed of delivery has increased dramatically, and we are able to deliver solutions in a fraction of the time and a fraction of the cost.
Okay, so when we talk about a data engineering project and a flow, there's really just 4 key elements. There's where am I getting the data from? Where am I going to process that logic? Where am I sending that data to? And then ultimately, who's going to consume it? And underneath that is going to lie a compute infrastructure to run that. And so some examples of what we see, might connect to Salesforce as the source, use Databricks as the processing engine, deliver the data to Snowflake, and have somebody consume that in Looker. And that can span multiple different clouds. Another slightly different example, more of a data science example, is I've got the data lake in S3. I want to source that data, again, process it in Databricks, push it back into the data lake, and then use a Jupyter Notebook to start doing some data science work on that. Okay. So when we talk about the data processing options, there's a lot of different choices. Okay, what you're doing is the ETL, or you might be doing ELT, or the transformation inside the engine. Is it going to run on-prem or in the cloud? Which Java runtime, or am I going to use Spark? If I'm using Spark, am I using Databricks, EMR, Cloudera, Hortonworks? Probably not MapR anymore. But the idea is that you have choices, and so this is that compute portability that we were talking about. So let me tell you about one other customer that's doing that.
Is a $40 billion company. We're one of the largest device makers in the world, and we make products ranging from servers to personal laptops, desktops, and mobile phones. Customer sentiment, customer experience is a huge important aspect. So how many customers say that they really like our T450S product? What do customers really think about our server products? The problem that we have right now is really a great big data problem. When you have billions of rows of information, how do you aggregate that up? How do you take that information? Talend became a very core component of this big data architecture. We decided to actually do a hybrid architecture of Amazon Web Services and our Lenovo servers.
Lucy Sky is our big data hybrid elastic platform that helps us to do real-time operational analytics on top of our data sets. Totally, we have 60 different data sources coming in into our platform every single day. Some of the data sources are like web data sets. When you get into a Lenovo.com, we gather the social information, what you talk about Lenovo on the internet, what are the comments that you're giving to us. There are a lot of chat logs, customer support logs. So we basically house around 11 billion transactions annually, and that keeps growing every single year. We have a capability to house around 6 to 8 terabytes of data in memory.
So we have this big data environment. What does it actually solve for us? We've been able to do some really great analysis. One of those analysis is the conjoint analysis, where you take 5,000 different combinations per device, and we're able to find what devices and configurations customers most care about. Through that exercise, we were able to actually drive up a revenue per unit by 11%. Over the last 3 years, since we've switched over to this big data platform, we've been able to reduce our costs by $1 million and by 34%, as well as get a 2.3x increase in our productivity.
Okay, so portable data processing, continuous modernization. You know, I would say that there's been a recent example in the marketplace with MapR. MapR was one of the leading Hadoop vendors. We had some of our biggest customers using MapR, and MapR went away. And then the question for those customers was, well, what do I do? For them, those that selected Talend, it was very easy. They just went and said, instead of deploying to MapR, I'm going to deploy to Databricks or deploy to another Spark engine. And so it was just a configuration change, recompile, redeploy, and then everything went out to that new environment. Okay, so there's a video coming up. I'm running out of time. I'm getting the hook here, but I won't show you the video. But this particular customer, whoops. So this customer had a multi-year journey, and they went from MySQL and Teradata using on-prem ETL to starting using Hadoop on-prem to starting using Spark in the cloud to starting using Redshift in the cloud as well. And so again, being able to simply swap out the technologies. So much like the MapR example, it's not just swapping out MapR, one Hadoop for another, but being able to say, I want to go from MapReduce to Spark, and I want to go from Spark to what's next. And so all of that's based on just parameters, that's applied to that data flow as opposed to rewriting in a new programming language. So, in summary, I would say give your development team that 3x advantage. Let them excel and deliver to the business faster with high quality deliverables. Give them the choice of how they want to process that data. So we're not saying you have to do it one way. Rather, the idea is that you get multiple ways to do it, and the developer gets to choose the best processing engine for the job that they're running. And lastly, let your team grow, with the technology as it comes along. Don't force them to learn a whole new programming paradigm, a whole new set of APIs. Rather, just let them understand the benefits of that engine or that technology and how to apply that technology and when to apply it, and then just change the parameters to be able to do that. So in essence, give your team that modern data engineering environment. With that, thank you very much.